considerations for designing robust and efficient systems. This visual guide beautifully illustrates 10 critical areas that every system architect must navigate. We'll journey through these interconnected domains to understand how they contribute to successful system development. Our starting point involves how different parts of a system, and the system itself, communicate with the outside world. This means defining clear and secure interaction points, choosing appropriate communication protocols, whether it's for web services, remote procedure calls, or data queries. Essential to this is safeguarding these interactions through encryption, verifying identities robustly, and defending against common online threats and unauthorized access. Configuration of these interfaces, whether static or dynamic, also plays a key role. Next, consider how to make your system faster and more responsive. A vital technique is to store frequently used information in a temporary, quickly accessible location. This involves deciding what information to store, how to organize it for rapid retrieval, and what to do when this temporary storage fills up. Measuring how often this temporary storage is successfully used versus needing to fetch data from slower sources is key, as is ensuring that the stored information remains consistent and available when needed. Another crucial aspect is managing how requests flow into and within your system. Often, an intermediary component will receive requests before they reach their final destination. This can be used to intelligently route traffic, provide an extra layer of security, or distribute the load across multiple servers. Different strategies for load distribution ensure no single part of the system is overwhelmed, operating at various network communication levels. Effective communication between different components of a distributed system is also paramount. Systems need reliable ways to send information back and forth, even if parts are temporarily unavailable. This involves ensuring messages are processed correctly, even if sent multiple times, choosing the right underlying transport mechanisms, and deciding how messages are queued and ordered. Whether components actively request information or have it sent to them, and how broadly messages are distributed, are all important design choices. Of course, the heart of any system is what it actually does. Clearly understanding the main goals and limiting the scope to achievable objectives is fundamental. It's about defining the core purpose, ensuring stakeholders are aligned, and balancing comprehensive functionality with what's practically achievable. This often involves making careful choices and compromises to deliver value effectively. A system is built for its users, so understanding them is essential. This means analyzing who they are, how many there are now, and how that number might grow. Identifying when they are most active, be it specific times of day or certain periods of the year, and how often they interact with the system is critical. Knowing how they access the system, whether through web browsers or mobile applications, and ensuring it's usable by everyone, are key considerations. How a system organizes, stores, and retrieves its information is a cornerstone of its design. This involves deciding on the best way to structure data, whether in traditional tables with strict rules and indexes, or in more flexible formats suitable for various data types like documents, key value pairs, time-based information, or interconnected relationships. Strategies for scaling data storage, ensuring data consistency across copies, managing access for different tenants, processing large data sets, and moving data into the system are all vital concerns. Underpinning everything is the actual computing power and storage. Designers must determine the necessary processing capabilities, memory, and type of storage, balancing speed and cost. They need strategies to increase capacity, either by making individual servers more powerful or by adding more servers. Managing the volume of requests, how tasks are handled simultaneously, and the use of virtualized environments or dedicated partitions are all part of this domain. Building systems that can withstand failures and remain continuously operational is a major focus. This includes having backup components, designing for fault tolerance, and implementing mechanisms that prevent localized issues from bringing down the entire system. In distributed environments, this means coordinating actions across multiple machines, managing containers, and overseeing interactions between many small, independent services. Being able to monitor the system's health through logs, performance data, request flows, and timely notifications is indispensable. Finally, the physical placement of system components in users has a significant impact on performance. Considerations include deploying resources in different geographical areas, using networks to deliver content from locations closer to users, minimizing the time it takes for data to travel, and efficiently resolving network addresses. Optimizing for these geographical factors is key to a responsive and positive user experience. These 10 interconnected areas provide a comprehensive framework for system design. By thoughtfully addressing the needs and challenges within each, architects and developers can craft systems that are not only functional but also scalable, resilient, and performant, ultimately delivering lasting value.